Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 242, I chat with THX Senior Vice President Laurie Fincham about his new amplifier technology. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded February 5th, 2015. Episode 242, THX Achromatic Audio Amplifier. This episode of Home Theater Geeks is brought to you by SmartThings. SmartThings lets you monitor, control, and automate your home from wherever you are using your smartphone. Right now, SmartThings is offering Home Theater Geeks listeners 10% off any home security or solution kits, and you get free shipping in the U.S. when you go to smartthings.com/twit and use the offer code TWIT at checkout. Hey there, Scott Wilkinson here, the Home Theater Geek and editor of avsforum.com. This week's guest geek is Laurie Fincham, Senior Vice President of Audio Research and Development at THX Limited. Hey, Laurie, welcome back to the show.
Hi, Scott.
So happy to have you here. Those of you who are tuned in to the live stream at live.twit.tv or logged into the chat room at irc.twit.tv can post questions for Laurie as we go, and I will pass along as many as I can. So what we're here to talk about today is a new amplifier technology, which Laurie has been working on for several years anyway, right?
I have, yes.
Called THX AAA Amplifier Technology. Tell us what AAA stands for.
It stands for Achromatic Audio Amplifier. Achromatic means without color, that's all.
Yeah. So we're going to be talking a lot about this during the show today. Without color, without adding or changing anything about the waveform that comes in compared to the waveform that goes out.
Except it's bigger, the one that comes
Except
out.
It's bigger. Exactly. It's an amplifier. What was the overall guiding principle that you were aiming for, that led you to develop this technology?
I think I mentioned to you on a previous outing that we had that it was developed as a lab idea when we were doing a line array, and we needed lots and lots of amplifiers. And we tried to use the ones that we tested in the lab, and the place got just baking hot because there was so much heat coming out of them. So we decided that we'd like to see what we could do to make an amplifier run cooler, but we didn't want to go to the switching variety because at that time, at least anyway, they were not as well performing as the best audio amplifiers. So then we said, well, why not? Can't we have an amplifier that's cool and small and yet approaches the sort of mythical audio quality of a Class A amplifier?
Now, when you said switching amplifier, another name for that is Class D. I want to make sure everybody understands that. And since then, Class D amplifiers have gotten better and gained more respect in the audiophile community, and they are extremely efficient. So they run very cool and they can be very small. But your goal was to not go down that path.
Well, because they have to be band limited, and you've got out-of-band switching. They're actually... and they're much more difficult to design. We wanted to do something that was easier to do, so we stayed away from it.
Always good to do something easy as opposed to something hard.
Yeah.
Easier, anyway. Yeah, right. Well, Class A amps are often considered to be sort of the benchmark, if you will, so to speak. We'll be talking about benchmark a little later. Considered to be the best sounding topology, as it's called. But they're very inefficient.
Yes.
Tell us a little bit about Class A amps and what's good about them and what's not so good about them.
What's good about them is that they have capability of being very low distortion, and the harmonics generally are low order harmonics, unlike Class B amplifiers. What's bad about them is that when they're sitting there just doing nothing, they have to dissipate twice the maximum power that they're capable of into the lowest load you're ever going to see. And so if you had a 100-watt amplifier into 8 ohms, but you wanted to work in 4, it would sit there just cooking away and giving you 200 watts. And so what happens if you want a big one, then you end up with a really big amplifier, and they're heavy and hot and expensive.
We have a picture of how Class A amplifiers basically work, and it's very simple. This is just a really basic picture just to show that a waveform comes in, it's got a single amplifying element, and the single waveform comes out. Couldn't be simpler, really.
Yep.
But as you say, it's very inefficient. So people came up with Class AB. And tell us about Class AB and how that differs, and what's better than Class A about it, and maybe what still doesn't work as well as you'd like.
What's better than Class A is it's much more efficient, potentially. What's bad about it is you're switching from one device to the other, and it's when you're going through that transition of 0 volts. You've got a positive rail and negative rail. When you're going through 0, it doesn't quite make it. And,
right.
And you get little discontinuity. That discontinuity creates high-frequency distortion and feedback, which, by and large, if you're trying to get distortion down, more feedback will reduce it. But feedback is band-limited in the sense you can't go above a certain frequency and use lots of negative feedback. You get instability and so forth. So ultimately, this crossover distortion, which appears in the higher frequencies, very difficult to get rid of, very difficult indeed.
We have a picture of how a Class AB amp works, and I just want to show that real quick. Here we have 2 output devices, one of which handles the positive swing of voltage, and the other of which handles the lower swing of voltage, and those things get combined to produce the final waveform. But the problem is, as you said, crossover distortion, which we have a picture of as well. And to take a look at that, we can see that you've got these 2 output devices, and the output comes out, but there's a little magnified section, and you can see that there's a little moment in the waveform as it crosses the 0 point where it distorts. It looks different than the wave should look, and that, as you say, causes high frequency, high order distortion.
High order, yes, that's.
And so that, so there you have the challenge of amplifier designers. There is a Class B, which I didn't really want to talk about too much because it only amplifies 1/2 of the waveform.
Well,
only
no,
the positive.
A Class B, a classical Class B, it does the top half here and the bottom half there, and there's no little bit in between. The problem is that it doesn't work, and so what we end up with is putting a little bit of bias into the output stage to try and smooth out that kink, and that's why Class AB amplifiers still get quite hot when they're doing nothing, because they've got current passing through them all the time.
So they're more efficient, but still not all that efficient. They still heat up quite a bit, and we all know.
Yeah, they heat up when they're doing nothing. That's really the point. So the standing dissipation, and particularly as you get more and more channels, you can be sitting there and you can have a home theater amplifier, and it could be dissipating 25 or 30 watts doing absolutely nothing.
Yeah, so as you said before, when you were designing this at first, you were trying to make little amps for line arrays of speakers, and they were all heating up the lab. you didn't need the central air and heat, the heating for sure, because they were heating it up just fine, and probably more than you wanted.
So we had 2 needs. We needed the line amplifiers to dissipate as little power as possible, so they didn't get hot when they were sitting there doing nothing. And they also had to be very quiet, because we were going to have nearly 100 of these on 100 amplifiers, and we didn't want to start hearing the background hiss from the amplifier. So they were 2 things we looked at with the technology. Can we make them run cool when they're sitting still doing nothing? Can we make them quiet? Can we get the distortion close to a Class A? And can we have it be extremely high quality? So that's, and we think we got close to some of those.
So it seems the AAA technology exhibits vanishingly low distortion, as it has been written many times now. How does it manage that? How did you manage to achieve that?
Well, we approached the design by looking at, first of all, there's two things we're trying to do. We're trying to make it run cooler. We're trying to keep the distortion down. One way that you can make an amplifier run cooler is to use a tracking power supply. So you have two rails, and so when it's sitting there doing nothing, it's just got the lower rail, and there's less heat going to be dissipated. That you can do, and the other way you can reduce the standing dissipation is to turn off all the bias. And that works wonderfully well. And you don't get any heat, but the distortion is dreadful. So you start from there. So then what you do is you start applying feedback, and then you reach a point where you can't get it any lower. And so what we use is a combination of feedback and feed forward error correction, feedback. And this is a fairly new idea. I think it was 1928 or 1929. Black, who was the inventor of negative feedback, has invented feed-forward error correction beforehand, but he couldn't make it work because he didn't have an amplifier that had accurate gain. He needed feedback for that. So
we have a picture. We have a picture of feedback to show people just to make sure that they understand what's happening there. And so what happens is the signal comes in, goes through the amplifier, and a piece of it gets fed back. Tell us a little bit more about how this process works.
Well, basically, this was Black's original pattern, and if you feed back, what happens is you can reduce the noise, you can reduce the distortion, and you can lower the output impedance of the amplifier. But you can only do this up to a certain amount, otherwise you'll have instability. So you have stability criteria, which limits how much feedback you can apply to an amplifier.
I mean, when most people think about feedback, they think about, you know, a guitar amp, or putting a microphone near a speaker, and that creates all kinds of squeals and horrible things.
That's positive feedback, though. Negative feedback, it actually wasn't believed for a while. Nobody really believed it was going to work, and so it took ages for Black to get his patent granted. And so in looking at our ideas on the amplifier, we went right back to the beginning to see if there were any clues as to how we could improve the amplifier design in the light of better tools. We have vastly better tools for design now. We can do circuit simulations and testing, and not have to make lots and lots of prototypes. And that was really the basis of this amplifier.
So what is negative feedback? Can you explain briefly what that is, as opposed to positive feedback, which is the microphone in front of the speaker, and it running away?
Negative is in antiphase, so it cancels out. It cancels out the distortion. Positive, and it becomes an oscillator. And at high frequencies, an amplifier can become an oscillator because of the phase shift through the amplifier itself. But feed-forward error correction, on the other hand, is intrinsically feedback can only lower distortion. It cannot remove it completely. It can get closer and closer. Feed-forward error correction, on the other hand, can, in theory, get rid of it completely. Furthermore, it never goes unstable. It's inherently a stable system, so you don't get any instability with it. But it's not that easy to do, and so that was really the challenge with this amplifier.
Unfortunately, I don't have a picture of feed-forward, a diagram to show what it's like. So can you explain a little bit more about how feed-forward works?
Well, you put a signal into an amplifier, and if it'll have a certain gain, and the signal that comes out will be bigger. Now, it's bigger, but if it has distortion, it will not be identical to the signal that went in. So imagine you scale those two signals, and you subtract them. You get the difference between the two. The bit that you don't want is added on the output. If you reverse the polarity of that and add it back into the load, then it cancels out completely.
Okay. So you take the input signal, the output signal, subtract one from the other, scaling them to be the same.
Yes. You're just looking at the difference.
And then you see the difference, and the difference is the distortion. That's what it is.
Yep. So then you invert it.
And you invert it, add those two things together, and boom, they're gone.
Yes. Well, you feed that back into the load. Yeah.
Yeah. And that goes back into the feedback circuit, or into the load? It goes into the load. Okay, which is the speaker in this case.
Yep.
Yeah, okay, good. Power rails are another interesting thing you mentioned earlier, and I do have a picture of that. I want to show everybody a picture of how these dual power rails work, which is kind of cool. Here we see a waveform. Tell us what we're looking at here.
When an amplifier is operating normally, there'll be some bias current running through the amplifier, and also in addition to that, you're going to have excess voltage across the output when you're not running the signal up to the rails. So essentially, an audio signal spends very little time near the rails, and it spends most of the time lower down, and the extra voltage that you have there is just wasted power. So an ordinary Class AB amplifier, for example, has a theoretical efficiency, I think, of 76 or 78%. It's pi over 4. And so what happens is, as you're running it, unless you put a sine wave through it, it would never be that efficient. With program, it's extremely inefficient. But if you have a low rail amplifier and only have the rail come up when the program demands it, then you can achieve much greater efficiency. And
so it's go back to that picture for a second. There you go.
Yeah. So what you're seeing here is the first rail is VSS. I think is it plus VS? Yes,
it's
plus VS.
Yeah.
Yes. And what you're seeing there, it's not strictly true. Let's say you were trying to play a sine wave like this, then the rail only comes on when the level exceeds plus VS. There's an offset between the two so that the tracking rail doesn't want to collide with the music signal. So you provide just enough volts to give you an undistorted signal out of the speaker. That's basically.
So basically you've got two what are called rails, which provide DC voltage.
Yeah.
And if the signal stays within the inner rails, the smaller voltage, then the outer rails aren't even used.
No, and let's say the ratio between the two was 2 to 1. Then the continuous rating of the amplifier with the lower rails would be a quarter of the output of the main amplifier. So it's like it's a 25-watt amplifier if the main one's 100 watts, but it only becomes a 100-watt amplifier when the peaks exceed halfway up.
Right.
And with normal program material, it's the amount of time that the signal spends above half rail is probably the order of 1%. It depends a little. Some rock music will be much more than that, but these peaks don't appear that often.
Yeah, I've often heard it said that, people try to want to buy bigger amplifiers, more power, and yet most of the time, except in certain cases, such as you mentioned with like rock music, they're really only outputting a watt or less. And you buy a 200-watt amp and you're not really using it most of the time.
Yeah, that's right. That's absolutely right.
Yeah. So, and especially if you have high efficiency speakers, you don't really need a 200, 300, 400-watt amplifier. Unless you want to damage your ears, I suppose.
Yes, but I mean, in theory at least, a digitally recorded program material could deal with very high peaks, and so below. Recently, I think, well, I say recently, over the last 10 years, increasingly, program material has been compressed more and more to make it sound louder and louder with smaller and smaller amplifiers. And a lot of this compression goes on even after the original recordings have been done. Somebody else gets hold of it and improves it. They make it more dynamic by making it more compressed. And so, but I mean, the loudness of program material is related to the average power that the amplifiers, broadly speaking, that the amplifier is delivering. The peaks have to do with just having them there and undistorted, so you don't hear distortion, or not having a clipper or a compressor pulling them down, and you can hear the change in the character of the program, although you don't recognize it perhaps as distortion.
Right. Another thing that you and I talked about offline is the power supply itself. And I guess this applies to the Benchmark amp, which we're going to talk about in a minute, which is the first commercial product available using this new technology.
Yeah.
Did you specify that you wanted a regulated or switching power supply in the basic design?
No, the spec for the amplifier came from Benchmark. They said, well, this amount of power, this amount of noise, and the best distortion you can get. The need for a switching power supply as opposed to the usual one, which is a transformer, is, well, one of the first reasons is that you'd like to have a device that can be used all around the world without having to change transformer tappings. Secondly, the transformers, if there are on there, are going to be very big and they're very heavy. And thirdly, they move up and down. That is when the demand gets on the line either gets high, you've got a lot of central heating on, the voltage from the wall socket is going to drop from 120 to 110 or even lower on occasion, so the peak output of the amplifier is going to be spoiled. And also you can get effects with the program material. If you use a switching power supply, you can make the switching power supply that does two things well. First of all, you can have it auto switch. It recognizes the input voltage and it will switch automatically from what you need for 90 volts or for 120 or 220 or 230 even in Europe. The other thing is it's much smaller, and when you get program peaks, you'll always have that level. So whether you're working it in Japan or in the UK, for example, if we say it's 100 watts, it's 100 watts exactly in both countries, so there'll be no difference. They're also smaller. The switching power supplies, though, are the very devil to design. You have to be very skilled. Most amplifier manufacturers don't have the background in switching supplies, so they normally put out specialists. But let's say you could design a normal transformer rectifier system in a few days. To do that with a switching power supply could take you 3 months, even if you were an expert. Everyone is different. They're amazingly different. But if you can do them, you can make them efficient. They run cool. They'll work under all conditions, and they will give this perfectly regulated. So we can talk about the performance of the amplifier, but some things it does are quite different from other amplifiers.
I was going to ask what the drawback of switching power supplies were and why more people don't use them. And you just answered the question, which is it's very difficult to do.
Yeah, they're difficult to do. They do radiate, so you have to go to a lot of trouble to make sure they don't put noise into the circuit and so forth. So, and that's what we spend a lot of time doing because we wanted to make an amplifier which was really quiet.
Right. And so that brings us to the first commercial product that uses this technology, which is from the company Benchmark.
Yes.
And Benchmark is well known for its super high quality DACs, digital to analog converters, which are used all over the world in professional settings. I've used them. A lot of people I know have used them. They're just fantastic. They're the benchmark. The company made its name very well because they are, in fact, the benchmark for DACs. And I believe this is their first power amplifier. Is that correct?
I think it's the first commercially available one. I think they may have made something for professional use maybe 10 years ago. But the attraction, the reason we got together, quite apart from, in fact, my colleague at THX lives quite close to Benchmark's factory, which is in Syracuse. We spoke to them, and it seemed like it was a good fit. They knew a lot about DACs, and they were absolutely fanatical about making their equipment work as perfectly as they could. And we toyed with the idea of sharing our technology with them so that they could make an amplifier that would get the best out of their DAC. When we came up with the name Achromatic, what we meant was that whatever came out of the DAC, the amplifier wasn't going to be in the way. It would simply make it louder. It wouldn't add any audible noise or any audible distortion. That was the plan.
Yeah, and so it seems to have succeeded. You have the amp there. We can turn a camera onto it and take a look at the actual product. It's pretty small. It's what, half rack space, half rack width?
This across here is exactly half rack width. So that's half of the 17 inches between the spaces, and the heat sinks on there are maybe 1.25 inches size. But it's not very heavy either. I mean, I haven't tried this, but you can definitely lift it up extremely easily. And
yeah, I hear it. I read a spec somewhere that it was only like 12.5 pounds.
Yeah. Yes, it is very small and very light. You can switch it on, and you can leave it on for hours, and it barely gets. You know it's not exactly at room temperature, but maybe at 7 or 8 degrees higher. It runs extremely cool.
Yeah.
And it will deliver 100 watts into 8, 200 into, well, 180 into 4, and it'll give a maximum output as a monoblock of about 340 watts or something like that.
380, I read in one review.
When we do the specs on these things, a lot of people increase the power output capability of their amplifier by going up the distortion curve. This amp will stay within a fraction of its 1 watt output distortion, right up to within under 1 dB of full output. So the distortion barely changes with level. Furthermore, it barely changes with the load either. You can work in 8 or 4. Typically, amplifiers exhibit much higher distortion in 4 ohms. This one is barely changes.
Well, it's really remarkable that it can be bridged. It has a switch on the back to bridge to mono, so you can use it as a monoblock or use it as a stereo amp, 2-channel amp. And I believe you said it will drive all the way down to 2 ohm loads. Is that correct?
The peak current capability of the amplifier is 18 amps. So you have the rail. It will be 40 into 8 ohms. It may drop a little bit into 4 ohms. So 18 amps peak is typically what it will do. You can burst it, and it will give more than that, but then the distortion will go up. So you're really running it too hard. We designed it so that it would work with audiophile speakers, which are notorious for having impedances that vary all over the shop. They're often quite low impedances. So we wanted to make sure that this wouldn't misbehave into any of those loads.
Magpie in the chat room is saying the main move for power amps is to displace the heavy, expensive power hot transformer with a switching mode power supply, less heat, far wider range of input voltage. Exactly what you were saying before.
Yes, it all makes perfectly good sense.
Yeah. Lawn Dog asks, is this an amplifier that can work with the RCA pre-out jacks on say an AV receiver or a pre-pro? And this is another interesting thing about this particular amp is its inputs.
Yes, well, the inputs on this are XLRs, and you can put RCAs in through adapters. But the other thing on the back panel, can we? If I turn it around, then maybe you can zoom in on this.
Yep, okay. There you go.
So you see the panel there. You'll see we've got a couple of switches on the back there. One of them allows you to adjust the input gain of the system, so that you can match it with either studio equipment, or you can match it with the much lower output that comes out of a player and so forth.
Right, of course,
so
because
you see the sensitivity. You can see the thing. It's in volts or dBu. You can see that. So you could say one was what you might call home hi-fi levels, and the other would be for studio work, because a lot of these amplifiers are going to be used in studios along with their DACs. That was really the idea. The speaker terminals, there are two types. There are the regular 4mm binding bows that you see here, which we're all used to, and then we have below those the professional speak-on connectors. You'll see these three sockets here. You can either have left or right, or you can use the middle one for getting a bridge output when you put the thing into bridge mode.
So those are line outputs that
No, they're speak-ons. They're the professional. Benchmark like to use them because they say that the wiping action of the contacts keeps them clean all the time, and the distortion's a little bit lower. The RCAs, of course, are much more useful for demonstrations and so forth. You can go in and out easily, and a lot of people like to use their existing cables. So you have the option. They both work.
The use of XLR jacks really indicates that what we're talking about are balanced audio signals.
Yes.
Which can you just briefly explain the difference between balanced and unbalanced, and why you would want to use balanced on this amp?
Well, balance is used primarily to get rid of earthing problems in studios where you have long line long cables running, and if you had the amplifier, say, behind your speaker at the end of the room, and you had your other equipment up at the front, you could use RCAs, but the danger is that you would pick up hum, and which you do. You can get rid of it, but it's much easier with balanced cables to get very low noise and make sure that no earthing currents are going to give you problems with it.
Right, or what we say in the U.S. Ground loops.
Yes, yeah.
And also induced electromagnetic interference, EMI, or radio frequency interference, RFI. Unbalanced cables like RCA tipped cables will have that problem. XLR cables, balanced cables, will not have that problem. Which is why they're used for microphones. XLR balanced cables are used for microphones because those cables often need to run very long distances.
Yes,
so,
but of course they have much lower signal levels down them too.
Also that too. Exactly right. Exactly right. Okay, so let's continue talking about this in a moment, but I would like to take a moment right now to thank our sponsor for this episode, which is SmartThings. Now, let me tell you about CNET's highest-rated smart home system called SmartThings. SmartThings allows you to monitor, control, and automate your home from anywhere using your smartphone. Now, your lights, locks, thermostats, home security are all connected through a single app. You don't need a different app for every product. Intuitive controls allow you to set the rules on your smart home through their free iOS, Android, and Windows Phone apps. With SmartThings, you can customize the way your smart devices talk to each other. So now you can tap "Good night," say, on your phone, and the lights will turn off, the thermostat will adjust, and the doors will lock. You can set your lamps to brighten each morning at sunrise or when you wake up, which for me is well after sunrise. So I'm glad to have that option for sure. And you can even keep your home protected with SmartThings with home security, motion detection, water detection, and more. You can enable your speakers. Here's a really cool feature. You can enable your speakers to broadcast dogs barking if there's motion outside the house. How cool is that? You can set up a camera to take a series of photos when unwanted motion or entry is detected. And you can have your doors recognize you when you are close and unlock themselves as you walk up. That's total Star Trek to me. There are so many ways to customize your SmartThings home. Hey, and SmartThings was named a CES 2015 Editor's Choice Award by Time.com, which is very cool. To get you started setting up your smart home now, SmartThings is offering Home Theater Geeks listeners 10% off any home security or solution kits, and you get free shipping in the U.S. when you go to smartthings.com/twit and use the offer code TWIT at checkout. And we thank SmartThings very much for their support of Home Theater Geeks. So I'm talking with Laurie Fincham, Senior Vice President of Audio Research and Development at THX Limited. And we're talking about the THX AAA, Achromatic Audio Amplifier technology, which is now implemented in the Benchmark AHB2, the amplifier from this company Benchmark that does such a great job with DACs. And actually, Laurie, you mentioned, and rightly so, that this amp actually forms a perfect pairing with their DAC because what's coming out of it is exceedingly high quality line level. And what comes out of your amp, their amp, which based on your technology, is an exceedingly high quality amplified signal, the same as what came in, hence the term achromatic, which then finally goes to the speakers, and you get to hear things as they should be. The exceedingly low distortion is something that's really interesting to me. They specify a signal-to-noise ratio of over 130 dB with a THD, total harmonic distortion plus noise, at under minus 118 dB, which is also 0.00013%, which is just incredibly low. Can anybody even hear that? I mean, is that well below the limit of human perception?
If you don't have to have distortion, why do you have to spend your time finding out where the limit is? I don't claim that I can hear the lowest distortion, but does that mean nobody can? Does it mean there are no circumstances under which distortion could become audible? I think you want to say, look, whatever sound is coming out of the speaker is entirely due to the source and not to the amplifier. The amplifier just makes it bigger. So I say if you can get it quiet and you can get the distortion vanishingly small, then you should probably do so. It doesn't cost any more to do it. It only costs the time that it takes to figure out how to do it and how to keep it the same all the time.
High Tech in the chat room is stunned and amazed that the amp doesn't have a digital optical in.
Well, it's because the Benchmark DAC does, you see.
Yeah, they want to sell their DAC.
And furthermore, when we were doing the amplifier, we wanted an amplifier where the choice of DAC didn't enter into some assessment of the amplifier. This was going to be a pure analog device from beginning to end. Anything else was the fault either of the speaker or the DAC, we felt, if we'd done our job properly. I mean, you could integrate things in there, but then you enter into the range of making integrated amplifiers, which change almost with the weather. The front ends are changing so rapidly now that we just wanted to concentrate on the power amplifier.
Well, that's for sure. I mean, the audio formats that integrated amps need to be able to decode and so on, you're right, they change day by day. And so if you have a good amplifier, it can last you years, decades. People still are using amplifiers now from many decades ago.
Yeah. So,
yeah. So, well, speaking of digital audio and high, I wanted to get into high-res audio as well, and that is certainly a hot topic today. And we're talking about, whenever we talk about high-resolution audio, we're talking about a frequency range that extends up beyond 20K, 20 kilohertz, and a dynamic range that extends beyond 16 bits, which is theoretically 96 dB of dynamic range. From the noise floor up to the maximum volume or level. And in practical terms, CDs, which are 16-bit, don't really get to 96 dB. They only get to 92 or 93, and they can only represent frequencies up to 20 kilohertz. And people, often cite that you need a very steep filter to prevent frequencies above 20 kilohertz from entering into the system, because they can cause some really nasty side effects. But so I want to talk about this Benchmark amp in terms of high-resolution audio and how it addresses those two needs. I know amplifiers can get above 20K very easily. In fact, I looked up the specs of this one, and it's got a bandwidth up to 200 kilohertz. So, okay, no problem there. What about the dynamic range?
Okay, well, I think in talking about high-res audio, that it's more important to think about the resolution in the audio band as such. That is, the extra number of bits does give you a greater dynamic range. That's absolutely for sure. Above 20K, there are arguments, and some of them may indeed be absolutely correct, that if you can reduce the rate at which you slope the anti-aliasing filter off, it improves the sound. Others claim that the sonic properties of a loudspeaker above audibility affects the sound in the audio band. I don't quite know how that's done, but if people are hearing consistently that there's an improvement, then high-res audio probably means it gives you a chance to hear what was in the studio. I think that's the best way to think about it. They would record it at 96 or 192, 24 bits. At the moment, you get a version of that which is compressed or resampled and so forth. If you want to hear what the artist heard or the mixer heard in the studio, then this is an opportunity to do this. If we can figure out a way of getting it to you, that I think, because streaming, I do stream high-res audio down, but it takes much longer than real time, and so this is what it's going to be a bit like video in a way. If we can't get it real time, then we've got to think about what we want to listen to, and then wait for it to download. Because the only alternative to that would be to put it on spinning media, and I don't really think that after the business with DVD audio, which really didn't go anywhere, I don't think we're going to go back to the disc. It's going to be wirelessly or on a chip or something like that.
What about Blu-ray though? I mean, I've had on some people from Sony talking about this pure audio initiative in which high-res audio is put on a Blu-ray disc and there's no video there. It's just 2496 or 24192. Do you have any hope for that, or do you think?
I mean, if Sony they have the catalog, don't they? I mean,
yeah, they do.
And they're a big supporter of the high res. One of them, they brought out a lot of nice pieces of gear for playing it. Look, if people want to buy the discs and they're considered to be affordable, but we've really changed the way we buy music now. We don't buy albums anymore. We're not spending $20 or $30 for an album. We're buying tunes or tracks or excerpts and so forth. So I think the biggest opportunity for it is going to be downloads. There's no doubt about that. We've got some big players in the arena.
We do, yes. And let's make the distinction between streaming, which I normally define as coming through over the internet in real time, versus downloading, which, as you say, takes longer than real time. You take a while, you download a tune, it's locally stored on your device, and then you play it from there. F-Loop in the chat room has asked an interesting question. Do you have a panel of quote-unquote golden ears that you use for, so to speak, feedback? Or that do you get people in there to listen to this amp and these technologies to see if you're in the right direction, or do you rely entirely designing on to spec and so on like that? In other words, the difference between subjective and objective evaluation.
Well, we think there's a strong connection between good objective measurements and the subjective sound, but in the end, it's the customer or the user who's going to say whether it sounds good. So what we do is we make it as good as we can, and then we give it to people to listen to, and they put it on. Benchmark certainly do a lot of subjective listening. They lend the amplifiers out to people who are making high-res recordings for shows and so forth. It will be the end user who determines. I don't think anybody to claim that you're a golden ears when you're my age or even half my age is ridiculous. I know what I like, but I leave that to the customer. If you like the sound of it and it performs as we think it should do, then good, that we've succeeded. If it doesn't introduce something that upsets you or disturbs your enjoyment of the music. I think listening to amplifiers, if you think about it, and we do think about whether we could do it more objectively, you've got to listen to it through a speaker. So straight away you're in a load of hurt, or you can listen to it with headphones.
You're in a load of hurt.
But because they all sound different, and they're all different in different rooms, and I mean, you can do subjective testing on them. Extremely hard, but how do you know that what you're hearing isn't the speaker or the thing? I still continue to give it thought, and we are working on some ideas where we might be able to put a more objective twist on it, but that's not here yet. It's bad enough bringing this to market, really. There's a hell of a long way from a bright idea that you have. It wasn't that I had, which is my partner on the amplifier who lives in England. He and I sort of chat about it over the phone. But from that first idea and the lab ones to get into the final product you see here, there were lots of things we did not anticipate, you know.
Like what? Can you give an example of?
Oh, well, you know, when you're in the lab, you don't worry about short-circuiting it. We don't put protection circuit on. No. We don't worry about little clicks when it switches on. When it has to be a product, it has to be damn perfect. So when you switch it on, it has to come up. We don't want any clicks when we switch it on. We don't want it failing if somebody accidentally shorts the terminal. When you put protection circuitry on, it has a nasty habit of coming in when you don't want it to. So we spend a lot of time finessing that and making sure that the power supply doesn't interfere we don't get any interference from that. There was an awful lot of work, probably a year's work from when we thought we'd finished it to getting like that. Then you've got to get it through regulatory testing. So you take it into chambers, check the RF, check the conducted emissions and so forth. It then becomes legal technical, and that can be a really miserable experience.
Well, I wanted to also touch upon the notion of tube amps. And it seems to me like this technology and the benchmark expression of the technology are kind of the antithesis in a way of tube amps. Even though it's analog, it's achromatic. That's in the name of the technology. And so there's no coloration from the input to the output, whereas tube amps are well known to color the sound often quite a bit, and yet they're still highly regarded and people like them. Well, what do you think's going on there?
Well, tubes are triodes certainly are inherently more linear than a transistor. That's a good thing. The second thing about tubes, though, is that they're generally for rather low power. You can't put a lot of feedback on a tube amplifier because you're going to get instability. You've got transformers in the way, maybe 15 dB of feedback, and they're generally low power, so they're 15, 20 watts and so forth. People like them. Let's say that the distortion that they produce, which is low order, is amiable rather than accurate. You know, if you believe, as I do, that you really want to hear what was on the program material, you don't want to add something to it, then you have to get the distortion down. Tube amps do have a sort of warm feeling. They also, interestingly enough, have quite a high output impedance as well, so they produce a sound that follows the shape of the impedance of the loudspeaker, so you get a bit of a bump at the bottom end. You know, if somebody likes the sound with that on, then it's a fashion thing. I don't think you should add something that the customer, you know, it's not our job to add to the sound. If you want to do that, play with it at the front end, but don't put it in the amplifier. Yeah. People like it. They like old open cars. They like Morgan cars, for example.
Yeah, right. So if you like that sound, maybe put a tube preamp on the front end, as you say.
Well, then you start getting noise and other things.
And this amp will reproduce it perfectly well, won't it?
Yes, it will. Yes, yeah. No, I think that in a world where everything is going down in price and is being mass-produced, and they're modifying everything, that there is a thought that going backwards is a nice thing to do. You know, I mean, we've got vinyl having a renaissance in the UK at the moment, and you could make technical arguments that this isn't as good and that isn't as good, but if the music that people hear on it is something that pleases them, then surely that is the perfect answer. I theorize a little bit that when you're playing music in the home with an LP, you would go to your cupboard, pull one out, take a look at the thing, take the disc out, put it on the player, clean it and lower the cartridge, sit down and then read the cover notes. We don't do that now. We go click and you can't find out what the music is. And let's say that there are two of you listening, for example. It's very rare that two people listening to the same piece of music are equally attracted to it. And so giving you something to read while you're listening, I think, is an awfully good idea. Plus, you can, by reading about the music, get to like it because you understand who the players are, you look for your favorite players or composers and so on. So I understand the appeal, and I'm not saying that I wouldn't listen to vinyl, but it would not be my first choice. I'm probably too lazy now. I quite like the idea of doing it remotely. But I still have that many vinyl discs. I can't say I played them very recently, though.
No. I've got 7 or 8 boxes myself, but I don't even have a turntable hooked up to my system at the moment.
So I bought them all again on CD. Maybe I'll buy them again on high-res, provided they don't mess around with the original recording.
Well, that brings up another point, doesn't it, that I've talked with a number of people about on this show, which is getting from the current release on CD, say, to high-res. How are they doing that? Are they remastering it? Are they simply taking the CD file and adding zeros, if you will, from 16 to 24 bits and so on, which some people are doing? So that's a whole nother can of worms right there. But this amplifier seems to me, again, would simply reproduce whatever it gets, be it the scratches and pops of a vinyl record, which it's going to have, and its dynamic range, which, as I recall, isn't much more than 60 or 70 dB. It can get up to much higher frequencies than 20K, but the dynamic range, I don't think, is really there. But whatever you want to put into it, this amp is going to deliver it larger, but otherwise uncolored. Yeah, exactly right. Well, and this amp, I must sort of say towards the end here, is close to $3,000. Yes. So it ain't cheap.
But compared with what?
That's the question, isn't it? Certainly, you can spend a whole heck of a lot more for an amplifier, but you know, you want to be, you're going to be a seriously committed.
It is for serious people. People who just want the best will go towards this. I mean, the DACs are running at $2 or $3 grand a piece.
Exactly.
This is just for the affordable ones, and they can be more than that. I think too, though, that people who are interested in sound reproduction and music as well, there's a pride of ownership, isn't there? I'm not going to buy an ugly car, and I'm not going to, or one that's scratched. So when I see my equipment, I want to see it absolutely immaculate in the corner, and I get pleasure from looking at it, even when I'm not listening to it. So they play into the party. We could have put this in a tin box, and maybe it would have been cheaper, or Benchmark could have done. But it wouldn't have the feel when you pick it out of the packing. Isn't that the first time when you unpack the thing and you go, oh, I'm going to love this, and you get it out, you can't wait to play it. I mean, that's the joy of ownership, I think.
Yeah, yeah. So do you believe, I'm looking at the chat room here, and Lawn Dog is saying that the company needs to base its objectivity on something. Having a successful product means people like it and buy it, but it's more important to find out why they enjoyed the sound. Can we even quantify that is one question. And there are a lot of amplifiers on the market, he says, and each produces a certain sound. Finding the one that people like is the trick. Now, there are those who say that if amplifiers measure the same, they sound the same. And then there are those who say, no, that is not at all true. Where do you fall in this? Well, they
don't measure the same. It depends what you're measuring. You know, if you're measuring bandwidth, okay, they're the same. If you're measuring THD and noise, that is a gross oversimplification. The harmonic structure of the output of the amplifier when you're feeding in the signal is the thing that differentiates. Crossover distortion, you'll rarely see people even showing what the waveform looks like when it's been added to the original signal because of that little bit in the middle there. I think a stereophile may be the only people that do it, but they don't put a scale on the thing, so you can't tell how big it is. So we look in detail at the behavior at extremely low levels, and we're not just relying on a distortion measurement with sine waves. I mean, that like I said to you before, we don't listen to sine waves anymore. We try to listen to music. So they don't measure the same. And once you put program through and you get dynamic things happening, which affects the power supply, you can apply feedback theory to the amplifier, but there are paths that are not in the feedback. Things are getting induced by tracks and so forth. And that's the tricky part. You always have to be on the lookout. And just when we think we've got it done, somebody will say, there's a funny little bit of something there. I wonder what that is. And we discover it's the layout on the track and so forth. So they're not really the same, and there isn't a one number. You know, you can't just say 0.1% is really good or a certain. It's a very complicated device, an amplifier. It looks like it's simple, but it's where it gets its power from, how it pulls through, and how it interacts with itself. So they're not all the same. And you can devise measuring methods and listening even with program where you can actually hear the difference in the quality of the distortion. And that, I think Hafler used to do something like that many years ago.
Well, it's a very good point about how you measure things is very important. And it's part of the objective subjective debate. You know, how do you get to those objective measurements, and what do they really mean? Somebody in the chat room here was asking, I can't really find it at the moment, about there's a temperature light on the, he noticed there was a temperature light on the front of the amp, and yet if you're saying that the amp typically runs pretty cool, so why would you need a temperature light?
You could be doing something silly.
You could short it out or something, I guess. Yeah.
So I mean, this amplifier is designed to be very friendly. So when you switch it on, absolutely nothing happens. And then lights come up and it settles, and then they all go out again, and you're ready to go in maybe a couple of minutes. So if somebody were abusing it, they could be measuring it with sine wave. Maybe somebody's interested to see what the distortion is like in the very low impedances. If you keep going, there has to be a point where we say, no, you can't continue at that rate. It's clearly not music. Turn it off.
Yeah.
Turn it off.
That was Lawn Dog. And I know Rusty Bones asked about break-in. And that's another thing. You just mentioned it, and I would love to hear you talk a little bit more about that. Break-in or warm-up time. Well, a lot of amps say you should wait a while before you play it because it's you know, it takes a while for the electronics to settle in and to reach its full potential, which is why sometimes people just leave their amps on all the time, generating a lot of heat.
In the case of Class AB amplifiers, we talked about bias, and this has an extremely low bias current. But in the Class AB amplifiers, they have to find an optimum value for the bias. You can have too little or too much, and a lot has been written about this. But that bias level changes with temperature, so the optimum bias level. So that if a good designer will design the amp so that if it's been running for some time, the bias is optimum at the temperature that the amplifier finally settles down. This doesn't do that because this is not getting warm. The bias current is so much lower than a normal amplifier. It's probably a tenth of the bias that they use on Class AB to get them. So there could, like, I don't know whether the temperature effect that they claim is something that you could measure, but, or that is measured, but I think there may be some merit in it if the designer has designed it when it reaches a stable temperature.
So that's what they're talking about when they're talking about warming up the amp?
Well, I don't know. I don't think they know about the technical underpinning of that idea. It's just people have a feeling that that's a good thing. Some of the amplifiers, of course, run so hot. It is certainly true that a lot of the devices do change their characteristics with temperature. There's absolutely no doubt about that. The capacitors are notorious for this.
Yeah.
And so there would be some sense if it was in a part of the signal path that could affect the sound quality. But this is more or less ready to go. You know, maybe a couple of minutes and you're ready to go.
Yeah, Lawn Dog said it has a Class A amplifier, runs better after it's warmed up a bit, but he absolutely does not leave it on to keep it warm. That's crazy. Well, unless you got a 3-dog night, as they say in Australia. And SSB 201 says, a Class D you can leave running, of course, whereas Class A, it's a very bad idea, certainly for your electric bill and well, maybe not for your heating bill. Well, there are reviews. I found a couple of reviews of this product, and I just wanted to make sure people knew where to go look for those. It's actually the review coming up in the March issue of Hi-Fi News, which is a British publication. We'll have a review of it. And you can also find a review on enjoythemusic.com, which is a sometimes sponsor of this show, and I'm grateful for that always. And they have a review of the AHB2 amplifier, as does Mix Online, which is the website for Mix Magazine, which is aimed at audio professionals. So they're looking at it from the professional point of view in the studio, whereas Enjoy the Music is looking at it from the audiophile point of view, and as is Hi-Fi News. So you'll have a few ways of checking out this amplifier in greater detail there to to see for yourself. It's been a wonderful conversation with you, Laurie, to hear about this new amplifier technology. What can you tell us about the future? Is there anything else that you're doing with this technology? Any other companies implementing it, or probably can't talk about it right now?
Probably that's true, yes.
Don't want to get the lawyers upset.
No, but we continue to look at the amplifier, and even though we've got it really good, maybe you can get it better, and or smaller, or whatever. So we continue to look at it, but we've stopped as far as this particular amplifier is concerned. So,
are you still looking at doing little tiny ones for those long line arrays of speakers?
Well, they weren't tiny amplifiers; they were 100 watts actually. So we had some problems with that because we had a total of peak capability of 10,000 watts, and we couldn't draw that from the line. So I don't know if you remember, we were running it off batteries. That was the only thing that would do it. No, I mean, we'd probably use bits of these if we wanted to do a line, because these run nice and cool. This is actually bigger really than it needs to be, because the heat sinks are on there, because Benchmark know perfectly well when people test them, they test it at levels that they never achieve it with music. They just like to put sine waves in and heat them up. And so a lot of that, you could get away with a lot less than that if it was for music only.
Wow. So they put on these big giant heat sinks. I was going to ask you about that too. They put on these big giant heat sinks for the reviewers and the people who want to exercise these things out to their max.
Yes, that's right. Yes, music will never get them warm at all.
Yeah. Wow. Well, that's great. Then I think we've learned a lot today, and I want to thank you so much for being here and explaining the THX AAA amp technology and as it's implemented in the Benchmark AHB2.
Oh, thanks. Thanks, Scott. And I apologize to the sound engineer for kicking my microphone around, so wherever he is, I owe you a beer.
Well, okay, you guys go out and get a beer, and I wish I were up there in Petaluma to join you, but I'm sure you guys will have a lot of fun. Of course, you can learn a lot more about THX at thx.com. You can find me at avsforum.com. You can email me at scott@twit.tv, and you can follow me on Twitter at htgeekscott and at avsforum. You can find previous episodes of Home Theater Geeks right here on twit.tv/htg, and also on our YouTube channel, youtube.com/twit Home Theater Geeks. Now, I'm going to start announcing at the end of the show, starting with this one and for the rest of February, that starting in March, 1 month from now, Home Theater Geeks moves to its new time of 2 p.m. Pacific, 5 p.m. Eastern Time. So we're moving ahead 1/2 hour starting in March. So be sure to mark your calendars so that you won't miss a minute of the excitement that is Home Theater Geeks. Next week, my guest geek is not yet confirmed, so I'm going to leave it a mystery for you. But you can be sure it's going to be somebody with lots of interesting things to say about audio and or video. So please join me for that. Until then, geek out.